Hey guys, thanks for all the suggestions and your encouragement. I am going to keep digging into the Wavetek 1080. I'm going to start out by clarifying a few things. One, service info. Yes, I did get some. However, I do not have a schematic for the main board or the front control panel, which is where 80% of the parts are. All I have is a parts placement diagram, and the jacks are labeled, the plugs, which are on the underside. Furthermore, the power supply. Yes, if I isolate the power supply from everything else, the voltages are dead on. In fact, if I hook up everything except for the half of the RF module that is the sweep oscillator, everything works. It just seems to be a problem when I hook up one part of this whole unit. In other words, the displays are fine. This entire board seems to be fine. Maybe. The front control panel seems to be completely fine. The power supply seems to be fine. You might be thinking, okay, analog, the sweep module, I opened it up. Is there a short in there? There was. There was a tantalum capacitor on the plus 18 volt supply rail that was shorted. It measured an ohm or less. I removed it and replaced it. That did not solve the problem. If I connect the RF module, I still have a short. I'm not sorry, I don't have a short. What am I trying to say? If I reconnect the RF module, it still dies. Now, if I measure the resistance on the RF module from plus 18 volts to ground, it's over 1 kilo ohm. So it's definitely not a dead short in there. Okay, so what does that mean? Well, a few possibilities. One is that, yes, when I check with an ohm meter on the sweep analog module, there's a highish resistance. However, maybe when power is applied to it, one of the semiconductors is turned on and it's presenting a very heavy load. And the regulators, the 7818 and the 7918 and the 78M05, they all have short circuit protection. If there's too much of a load on them, they shut down. The 7818 and 7918 can both do 1 amp. Now, when I reconnect an analog module, this is the plus 18 is when I did the shorted cap. When I connect the RF module, both the plus and minus 18 go essentially to zero. They're like 0.3 volts or something like that. The 5 volt rail keeps chugging along, no problem there. Now, these are not just conventional regulators because they have these op amps that tie into this reference to make them more precise. I got a suggestion. We'll just ground these points. I want to be careful with that because I mean grounding the output of this op amp, which is probably okay because there's a current limiting resistor in here. Also got a suggestion to bypass these entirely and power from external supply, which I can do. I have an HP 6228, which can do dual supply up to 1 amp. So that should be perfect. And I can put it in tracking mode, so when I put one side on 18, the other side will track it and also do 18. So I can do a plus minus 18 supply. This also, I can dial in a current limiting crowbar if I want. So it can, like if I set it to 0.5 amp, this would turn off when it got to 0.5 amp load. We can certainly try that. I'm also curious to take this device. I put a simulated load on it. I think I used 330 ohms or something like that. I didn't realize at the time that's not a very heavy load. I could put more like, well, it'd be 18 ohms would represent a 1 amp load. I'd need to use some power resistors for that because they're gonna get hot. It'd be 18 watts of power dissipation, so I'd need something like a 25 watt power resistor. But I could certainly try that. So I'm thinking there's two possibilities. One is when that tantalum cap shorted, it damaged something else that only presents itself when the RF unit is hooked up and it's drawing a heavier load. So it might have damaged something. It can, and that cable doesn't go to the power supply. It goes to this board. So when that tantalum cap shorted, it may have damaged something on this board or the power supply that doesn't present itself unless that module is connected. Or there's something in the module that's damaged and it presents a heavy load when power is applied to it. So another suggestion I got is just power up the RF module directly to an external power supply and not this, and see what it does. I think I can do that. I don't appear to have the printout of that page, but it takes plus minus 18 and plus 5. That I can't do with this dual supply. I don't have a dedicated 5-volt supply readily handy. But I don't know if that's used for anything that we care about. There's also a couple control signals in or out of it. Like, well, there's the sweep voltage input. Maybe I could just ground that or something. In other words, there are about 6 wires going into it. So it's not just plus minus 18 volts, so it might be a little tricky to power it up on its own, but that is absolutely an excellent suggestion. So what do we want to try first? I'm going to do the simplest thing first, which is I'm going to try putting a heavier load on this power supply with the RF module disconnected. And if that turns out to be okay, then I want to try powering the plus minus 18 from an external source and see where that gets us. Because one suggestion I actually got from Shango was, hey, when you're in a situation like this where you think there's a bad component and the device itself can't supply power, use an external supply that has a lot of current to smoke, to roast whatever shorted, so you can tell, you can see the smoke, or you can find the hot spot to want to identify the bad components. Also, I did get my parts that I had ordered for this. I don't know where my brain was, though, unfortunately. I ordered a bunch of caps. I didn't think. I don't know why. Well, I know why, because I'm so used to recapping. It didn't occur to me to order some semiconductors. I should have just ordered up some new voltage regulators and some bridge rectifiers or whatever. Those parts are so inexpensive. So unfortunately, if I do find there's a problem with a semiconductor, I don't have any replacements on hand. I'll have to place another order. But at least we can muddle around with some troubleshooting right now. Also got a comment asking if I had checked the capacitors for high ESR. Well, here's the thing. Even if the power supply caps are bad or have high ESR, that wouldn't create any of the problems we're seeing. There just might be excess ripple in the power supply. It's a linear power supply. It's not switching. So if the caps go bad, you just get more ripple in the power supply. It doesn't cause there to be no power. You just have noisier power. Oh, all right. Let's take a look at these new parts, too. I'm curious to see what some of them look like. So I did axial caps. They are still made. In fact, I think there were 1 or 2 lines that are actually new at Mauser, like somebody started to produce a new line of axial caps in the lower voltages, because they are definitely being phased out. They're getting harder and harder to find. But at the lower voltages, they are still being made, and there are some new ones being made. But for some of them, like the tantalums, just to save some money, I did get the axial. So I got the radial versus the axial. The axials can get really, really expensive. But I did get some. In particular for the RF unit, because there's very little room to work on. So these are for the RF unit, and these are for the power supply, where I can just bend the leads and replace axials with radials. I did get some new caps for the power supply. There's just 3 of them. No big deal. you might be thinking, well, why tantalum? Who cares? Just replace them with electrolytics. They have special characteristics. The capacitance is good over a huge range of temp. They're spec'd out to like minus 55 to plus 125. They do not have a shelf life. And they don't lose their capacitance over time either. Generally, I read you can replace them with ceramic MLCC, high density ceramic caps, but those have somewhat different characteristics when it comes to ESR, and you might actually have to add a series resistance to them, and it was getting too complicated from what I was reading that I didn't want to mess with it. I figured, okay, I'll just spend a bit of money. So this little handful of capacitors was about $40. These guys, even in this package style, we're still talking $1 or $2 each. But so be it. That's certainly a lot less than having to buy a whole new sweep generator. Let's give this a try. 40 ohm load right across the 18 volt line. Here we go. No problem at all. So that represents a little less than half an amp, the additional load I just put on it. So I'm thinking that that's not the problem. I'm going to disconnect the ground on this. Well, no, here, I'm going to leave that as is and hook the RF unit back up. Let's try something else here. So I have the unit turned off right now. Let's check the resistance here. It's about what the resistance of this is right here, of course. So let's disconnect this end. And I'm curious to see what the resistance is on that 18 volt bus with the RF unit disconnected and with it connected. So about 0.9K. So that's about what I saw on the RF unit, that it was about 1K on the 18 volt bus. Let me plug that RF unit back in. So the 18 volt bus can pump out current. So let me get back to my unfortunate theory. Now I haven't checked the negative rail. I've kind of been focusing on the positive because that's where I found this shorted cap, but maybe the problem's in the negative rail. Maybe it can't handle a heavy load, so we'll check that too. This thing is unfortunately the connector that is giving me trouble. Or the RF. The RF unit connection is the most difficult one to get at. I keep taking it in and out. There we go. Okay, it's 500 ohms. So when I tested them independently, I get about 1K load on either one, and together they're half a K. That makes perfect sense. But now if I turn it on, put this back in volt mode. Interesting. I never checked it while I powered it up before. So briefly, it was over 3.5 volts, and then it slowly dropped. So it's clearly not a dead short, and it looks like something is putting on a really heavy load and slowly dragging it down. Now I was asked about what's the input to the regulator. Okay, let me try this again here and pay more attention. So 2.5. When I first turn on, it goes to overload. Of course, it's an auto-ranging meter, so I don't. Well, actually, I can use some of the modes I never use on this. Let's see. It doesn't do what I'm trying to put this in min-max mode so it can capture the peak. Oh, that's how you reset. I'm not sure how to do that. I can force the range. Excellent. Okay, let's give this a try. So I turned the auto ranging off, and now I'm forced it to be in this higher range. Okay, it peaked at 3.2 volts. Okay, okay. Let's check the input to the regulator and see what we get there when it's being loaded down. It is low. It should be around 25 volts. Let's check the negative side of things. So it is getting loaded down. And the negative 18 volt has gotten minus 19. Oh no, okay. So I've been misspeaking. The negative 18 volt rail is actually minus 19 when we've got this problem, and the input to that is just fine, minus 25 volts. So when this thing is operating correctly, it should have about 25 volts plus and minus on the inputs to the regulator. So it's being really dragged down. Now what I'd love to do is see how much current it's drawing. To do that, I need to break the circuit and insert an ammeter in between, or find a handy resistor that I can measure a voltage drop across. I don't think such a thing exists, though, because there's no resistor in the circuit. Full bridge rectifier, filter caps. Yeah, there's nothing. It's just a regulator. So see the current draw on the positive side, I have to break the circuit somewhere and stick an ammeter in between. Okay, time to experiment. I pulled the positive 18 volt regulator out, attached a wire to where the output of the 18 volt regulator would be, and I've connected it to an external power supply that can do up to about an amp. Right now I have my voltmeter on that just to make sure that it's dialed in correctly. I'm going to turn it off for a moment and hook it up to the device. I'm going to turn this on. I'm going to turn the power supply on. Let's see what happens. So turn this on, we have nothing. Oh, I turn this on too. Okay, no displays, nothing, and no voltage. Okay, let's go with this. And that's weird. 3 volts again, but it was only drawing like half an amp. So what's going on? Oh, maybe I have current limiting turned on. Oh, I do have current limiting turned on. Hang on. Okay, yeah, no, this this isn't happening. I disabled current limiting, so now it's putting out over an amp, and where voltage is down to like, it's not even a volt, is it? Something's got to be getting toasty. About 2 volts at about an amp. So something's sucking up 2 watts of power somewhere. I don't smell anything. 2 watts isn't a ton. But yeah, so it's definitely not an issue of the power supply not being able to put out enough power. So we've determined that. It's something is sucking that power down, and it's got to be something in the RF module that's doing it. So, time to dig into the RF module. Alright, let's look at the service info a little bit. It's easier to see on the computer screen than when I print it out. The printouts just don't come out very nice. So, this is what I pulled out. Feeding in 18 volts right here. Now you might be thinking, hey, maybe these parts are bad. Remember, with the RF unit disconnected, we do have plus 18 volts. And it's powering other parts of the circuit, so I don't think that anything can be wrong here. So let's just jump right down to that RF unit. Remember, I don't have schematics for the main board or the front panel, which also have 18 volt connections. Okay, so here is the RF sweep unit, a portion of it anyways. Here's where the power comes in. Plus 18, minus 18, plus 5. This is the cap that shorted. And it's the one that I have tacked in a replacement. These, I just clipped them out. These caps aren't in circuit anymore. Sure, maybe this one failed. I'm going to dig back into that box in a moment and we'll take a look. But let's see, what does that actually go to inside of this box that we could check out. Okay, plus 18 here. 620 ohm resistor, and then a 39 into a VCO, which is a sealed metal box. That would be a nightmare to dig into. However, we have a 620 ohm resistor in series with it. So even if this transistor was a dead short, that should limit the current. But we can check that resistor for sure. Plus 18 here, 68K resistor. That's a very large value. That's not going to be sucking current down. Down here we have plus 18, again, current limiting resistor into a sealed metal box, fixed oscillator. No hope of really digging into that, but we can check that resistor. Maybe that's shorted, maybe that's shorted. Okay, then we get into these guys. These are microwave amplifiers, MWA 320s. Plus 18, again, 1K current limiting resistor. And that, I think, is it for plus 18 on this page of the schematic. This is plus 5. Okay, let's go to the other side of the schematic. Plus 18, come over, 100 ohm resistor, 4.32K resistor, 100 ohm resistor. Those would all limit the current. We have a cap here. I've also clipped that one out. If that had been shorted, these are in parallel, so it'd actually be a 50 ohm load. That would suck things down. I better make sure I disconnected that, because if that's shorted, a 50 ohm load. But then again, when I check the resistance between this and ground, remember it's about 1K, sorry, in this box on its own, when there's no power applied. That's the weird thing. Now, if this, could one of these caps, let's pretend that's in circuit. When you use a multimeter to check resistance, it puts some voltage out. What that voltage is, I'm not certain, I'd have to check, but it's fairly low. So, we're looking for a device that when we put a small voltage across it, does not present a heavy load, but when it has above a certain threshold, which appears to be around 2 volts, 2.5 volts, then suddenly it's looking like a dead short. Could a capacitor, a tantalum cap that's somewhat failed, could it present a higher resistance at a lesser voltage? Maybe. I think it's more likely we have a semiconductor that's bad. It's right there in the name, it semiconducts. It kind of conducts, depending on what the conditions are. But anyway, so there's that plus 18. We have resistors in here. Again, yeah, if one of those failed, that would be a problem. You know, shorted. Boom. Boy, we don't have plus 18 going anything else down here, do we? Until we go way down here. Okay, it's a 20K variable control with a 47K resistor off the arm. That's not going to present any load. We have an 18 volt here going through a 10K and then 4.7. That's a very large load. I don't see plus 18 going to anything else. And this is it. This is all that's in that box. So these are curious devices. If you're not familiar with these microwave amps, they've been around for a while. They're kind of neat things. Inside, I believe there are several transistors and probably some discrete components. They're linear amplifiers that can do a huge range, like 0 to several gigahertz. And they just have 3 connections. Input ground and then output power. Well, how the heck can that work? It seems like you should have four pins: input, output, ground, and power. They do double duty on this, but you have to decouple it, either with an inductor, which will block the RF from getting back into the supply, so you can have the power coming down here, but still have a signal at this point. Or here they just use a resistor. Seems like an inductor would be better, but they chose a resistor. So if that 1K resistor is shorted, yes, that could be a problem. But if this amp is shorted, it shouldn't be a problem because we have 1 kilo ohm limiting the current. And it looks like this one gets its power going up and up and up and up and up from the 5 volt supply. I think these are meant to run on like 2.5 volts or something like that. Which, hey, maybe there's something in that. That's about when this thing starts dying. And what about the ones over here? Wasn't quite sure where these are getting their power, so we have all 3 of these come up together and go over to this line. What is that? That's... oh man, why? I think that's going to this point. Back up a little, so we have 3 horizontal lines. 1, 2, 3. It's the power, it's the topmost line. It's got to be this point. So those are all going off the 5 volt rail, which makes sense because they run on just 2 or 3 volts. So it makes sense that they won't be going to the 18 volt supply. So this is all good because there are very, very few things to check. But I'll tell you, I didn't show you guys the back side of this unit. I will in a moment. This is a very intimidating looking little metal box inside. So we are going to check that resistor. We are going to check that resistor. We are going to check that resistor. And that resistor. Double check that cap. The one I tacked in a new replacement. I may have fried. We're going to check these 2 resistors. We're going to check that cap. And that's really it. I'll take a brief look at this, but that just doesn't seem possible. Oh, I thought that was plus 18. It's minus 18, so that can't be an issue. Alrighty then. That's what we're going to do. Okay, I have removed the RF unit once again. I showed you this side before. This is just held on by tension. Alright, so this is the RF side. And that was the cap that shorted out. And I tacked in a new replacement. And these are the 2 I just clipped out. This is the marker side, which has its own separate power connector and does not seem to be a problem. This is the cable that I've been disconnecting and connecting. When I have it disconnected, the set powers up, the displays power up when it's plugged in. No. Now what I didn't show you was this side. It's a screw on either end of the box you have to take off. Pry the shield off. Whole lot more going on here. So this is the bad side. These are those 2 metal boxes I said that we have really no hope of getting inside of and doing anything. And there's a whole bunch of circuitry. And there is another 1 microfarad tantalum cap, and it may not be obvious, but I did clip it, so it is disconnected. Now there is an op amp here. That could also be, I forgot to look now, I printed out the schematic. I don't think the op amp, I don't recall seeing what that was powered by. Oh, sorry, I totally glossed over that when I was going around and around the schematic. The 4558 op amp is also powered by plus 18 volts. That's why I was kicking myself. I didn't order a new one when I was ordering from Mauser, but I could pop it out of the socket, I suppose. What chaos might that cause? Sweep sample level. It looks like that's part of the circuitry that provides. So I believe it samples the output of the sweep gen to maintain the output level, so that goes to an AVC circuit. So that might not be the end of the world if I just pop that chip out, but because I don't really know how to test an op amp other than to pull it out and power it on a breadboard or something. But yeah. Alright, so here's the 200 ohm resistors I wanted to check that are just in parallel. That's easy to get at. I don't know what that is. BF something. I gotta guess as to what that is. There's one part that had kind of a strange part number on it. Oh, maybe it's this. Maybe it's this mixer. Oh yeah, no, I was thinking of these NE. I think they're NEO 2135s or NE0 2135s. MWA. Well, one of these is different. They're 3 MWA 320s. It looks like this last one is a 330. Might that be it? No. So those microwave amps I was talking about, that's what these cans are. 1, 2, 3, 4, 5 of them. It's hard to see that part number. Anyways, I will dig through this and try to identify various parts. Ooh, boy, that's hard to get at. So there's a model 1080 and a 1081. One has a 50 ohm output impedance, one has 75. And the only difference between the two is a resistor. It's that. So that is what couples the output, couples the signal generated in this to the outside world. That poking out of there is a 47 ohm. I have the 50 ohm version. I would like to have the 75 because everything I do is TV work, which is all 75 ohm for the most part. But that does not look it's easy to replace, does it? Alright, so I'll go through here and I'd try to identify all those key things we were talking about. Boy, some of these parts look so strange. Like, what are these? There's metal cylinders that are grounded with a part going through them. I see 1, 2, I see 4 of them. What are those? Are they these diodes that have kind of a box drawn around them, maybe? Or are they coils that have shields on them? I'm not serious about this transistor too. It has these radiating things coming out of it. Maybe that's that device attached to the side. Obviously I don't work with RF stuff much. Oh, maybe these are those shielded things. Well, those are feed through. Yeah, maybe they're these. I don't know. Alright. Give me some time. I'll dig through this thing and see what I can come up with. Okay, here's what we're going to do next. I identified... I checked all the resistors as best I could. They all check fine. So we're going to try powering this up from my bench supply. No 5 volt, just a plus minus 18 and ground. So we have that going on here. And we can monitor the voltage and current on the supply itself. So let's zoom in on that a little bit. I already dialed it in to plus and minus 18 volts. I'll put both of these in. Oh, here I'll, oh, there. Let's just go for it. Oh, and right away, the 18 side is getting dragged way down and it's drawing a ton of current. The other side, oh, there we go. No current. Okay, so now you can see what's getting warm. The op amp is a little warm. It's a little warm. Now we're drawing that little. Oh, I did dial in the current limiting too, so it's only at half an amp. Let's let it rip. I'm really. All right, something's getting hot. Now I can smell it. What is it? Oh, there. Now I can see. What was it? Damn. Oh. Son of a... How is that possible? The new tantalum cap I installed. The new tantalum cap I installed went up in smoke. What the? Are you kidding me? Are you kidding me? Are you telling me that the original was bad, I put in a new one and that was bad, and that's been the problem this whole time? And it... Oh my God! If that's it, well, I'm happy. It just wasted some time. All right, let's power this up again with that cap out. Okay, it's drawing current, but not that much, and we have 18 volts. Son of a... It's drawing 180 milliamps. Seems reasonable. Oh my God. Does everybody hate tantalum caps as much as I do right now? So the one that I put in there, so some years back I bought an LCG 400 test pattern generator, which is a cool device, but it's kind of primitive. It's about from the same era as this, and it generates a bunch of cool patterns, but it does it with a ton of integrated circuits and transistors. There's a massive circuit board, and it was loaded with those teardrop tantalum caps, and a number of them were shorted, so I shotgunned all of them, and I had some left over. That's where that tantalum cap came from. So I bought it 8 years ago, 10 years ago, and it's been sitting around, not doing anything. So why did it fail? Did I install it backwards? It's not possible. I mean, I don't think I did. Now that it's charred, I can't really tell because I can't see the markings on it. Okay, well, here's what we're going to do. While I have this out, because it's such a pain to put everything in and out, in and out, in and out, I'm going to take my new caps and I'm going to install them. And then I'm going to reinstall this, put it all back together, and see if it works. You know what? I do believe it is my fault. I installed it backwards. There's a line on one side. I assume that meant it was negative because I'm used to electrolytics where the marked side is negative. On these guys, that's the positive. There's a line, it's a little charred, but there's a line going along the top here, and that's what I had going to ground. So I installed it backwards. On the bullet ones, the chamfered end, that's the positive end. That one I do know, and that's what I'm going to be installing in here. Alrighty then. I'll get to it. New caps installed the right way. I hooked it up to plus minus 18 volts, and it's drawing about the same 400 milliamps on the 18 volt rail. We have 18 volts, so that seems to have fixed it. I replaced a couple other tantalums on the other side of this. The ones on this side I'm going to leave in place because I don't want to risk damaging anything. If this unit has problems, I will immediately suspect those and install new ones. But for now, I'm going to seal this puppy back up and reinstall it. I am so glad I took lots of reference photos. This thing is not obvious how it goes back together because some of these cables are much longer than they need to be and they just snake all over anyways. Are you ready? Are you ready? Here we go. I won't know for sure this is working until I get it on some test equipment. Okay. Alright, let's see if this still works, and assuming it does, I'll show you what it can do and why I care about it. Yes, it is working. By default, when you turn it on, it goes into full sweep mode. There's also Delta F and CW. Full sweep, I believe, means it sweeps over the whole range of this device, which is 1 megahertz to 1000 megahertz. This is meant for the cable TV industry, I do believe, which had channels going into the, from channel 2 up to into the hundreds, so it had a very large bandwidth going down that cable to support all those channels, and I'd want to make sure that a signal was getting through and there weren't certain frequencies that were getting attenuated, so this could accomplish that. But we want to use it for aligning TVs ideally. So the Delta F is a little more interesting for what we want to do. Let me dial this down. This is more like a conventional TV sweep generator where this sets the center frequency and the sweep width controls how much the sweep action is. So it says here, sweep width, this is a rotary switch, it says times 100. So on 0, I believe that means it goes from the lowest end, sweep up to 100 megahertz. So if I have this on 9, I think it means it goes from 9 megahertz. And if I do this to the max, it goes from 9 to 100. Something to that effect. I honestly don't pay too much attention to these controls, just to get a rough idea. I really need to rely on the markers and the XY display I'm looking at to know exactly where I'm at with the frequency. This gives you a pretty good idea of what frequency area you're in. This little knob over here is a fine control. This is pretty coarse. This goes, it's a multi-turn, it's like a 10-turn pot, and it goes from, well, from 0 to 1040, which is the full range. Unless we're doing a tuner, which we might get up to a couple hundred megahertz, we're going to be way, way, way down here for doing alignments. So maybe if we're doing a 22 megahertz IF device, we dial this into around 22. It's a little twitchy, as I said, so you can use this to fine-tune the frequency. Now, CW mode is continuous wave. There's no sweep. So this should be putting out around 22 megahertz right now, which can be really handy for peaking coils. However, is that 22.1, 22.5? That's not reliable enough. I would definitely want to use an external frequency counter if I was going to be using this as a precise RF source. That's why I use my 8657 in the background. Okay, so those are the major function modes. Now let's go back to the Delta F mode, which is where I would normally use this for sweeping, and let's put a pretty small sweep amount in there. The sweep rate, you do line, which means it's sweeping from the low frequency to the high frequency at the line repetition rate, which here is 60 hertz. So 60 times a second it's sweeping from low to high, which can be a little too fast. That can affect the response curve of your device, so you might want to go a little slower, in which case this control here also controls the sweep rate. Now notice we have a sine wave and then it's just flatlining for a while. That's the return and overall on your display device. So it's sweeping low to high. Then when it starts over again, it does a blanking interval. And the faster I go, the shorter that interval is. So this can go really slow if I go all the way down. And there is a fast mode. This is the lowest sweep rate on the fast mode, and if I go higher, now if I change your time base, now you can see those intervals. So that blob there is the sweep portion, and the line is the retrace interval. Now, the last major thing this can do is markers. They can do them at 1 megahertz intervals, 10 megahertz intervals, 100 megahertz intervals, and you can control the width of the markers and the size. The markers are little blips that will appear on your XY display, which will let you know. So say I'm sweeping 15 megahertz to 25 megahertz, and I just put the 10 on. When it hits 20 megahertz, there's going to be a blip. If I was sweeping 15 megahertz to 45 megahertz, I'd see a blip at 20, and at 30, and at 40. If I put it on at 1, I'd see a blip at 15, 16, 17, 18, 19, 20, etc. Now, what's cool is if you pair this up with a nice big display like this, it has a grid on it, and you get it lined up right, the grid, every vertical line on that grid will be a 1 megahertz interval. That's how I typically set it up. And with the aid of these markers, and tweaking the gain and the sweep width and all that, you can make that happen, which is really nice. So, oh yeah, the last thing, output level. Yes, I can vary the output level. The switch is hard to turn. It's always been hard to turn. It's a really complicated looking rotary switch inside of a can that's sealed. I'm not going to mess with it. I can turn it. It's not a big deal. It's just, maybe that's how it's supposed to be. It just seems a little stiff. So this seems to be fully working. I'm going to pop the PSU board out, power supply unit, and recap it, and then button this thing all back up together. All recapped, reassembled, paired up with the Wavetek XY monitor, and it is working just as it should. So now we can proceed with the alignment videos. It was an interesting journey in the end. If I hadn't put that tantalum replacement cap in backwards, would have gotten to this point a heck of a lot sooner. Hope you enjoyed the journey.